All right, day one of the International Builders Show. Here is me walking around, seeing what I think is interesting from the perspective of the science of homes. I'm gonna be wearing my bag for the whole video because I have test instruments packed in here. I'm also monitoring our carbon dioxide, which is 920 right now, and even carbon monoxide, because you know that they like to have those ventless fireplaces in here, so we'll be testing that. This is Solus. They make fire pits. And right now I'm running a test on the particle counts coming off of these and also the carbon monoxide. We might not have the results in just a second here, but I wanted to say that I'm just talking to my friend over here, Chris. I was like, are these for inside? And he was like, no. Why? Gross. Don't do that. Carbon monoxide will kill your clients. Don't kill your clients. And I was like, I like you. What about the ethanol indoor thing? He was like, well, you can do ethanol. I was like, well, I wouldn't. He was like, well, I wouldn't either. But so anyway, Chris and I are on the same page. And I just wanted to remind everybody that chimneys and open hearth fireplaces in airtight homes are a bad idea. And the solution to that is not to get rid of the chimney and just start burning stuff inside of your home. The solution is like, find a better way to get your kicks. Let's do that instead. So we're in the green on the particle counter, and carbon monoxide right now is still 0. So this is very clean. But just wanted to say that carbon monoxide is created when you have incomplete combustion. So the more dust and gunk falls on these burners, the more it impinges the flame, and it'll create more carbon monoxide that way. Thanks very much, Chris.
You're welcome. Thank you.
I know you guys really like your actual fire, but hear me out. It's just, if you're just looking for mood, right? You know? I mean, do you need real flames or do you need a picture of flames? This is so much better. How wet exactly do we need to be when we're showering? Is it overkill? Is it too much? So always on the lookout for different stuff. And this is a little different. I'm not sure what it means, but I just wanted to show it. So this is a heat pump that's a window unit, but you can see that it's actually just the line set that's going out through the window. There's an outdoor, a compressor, and so it's technically like a split system. It's a ductless mini split, just a different shape. So you just open up, it's gotta be a single or double hung window that you put it out through, and it can be installed by 2 lay people. You don't have to be professional. It plugs into 120 volt power. So if you just have a plug in the wall, you could actually power it with that, and it's a 3/4 ton unit, which is probably a little big for a lot of rooms, but like the fact that it can heat and cool, and the fact that it does something that a lot of other window units wouldn't even be able to do, that's kind of interesting. So cool, check it out. I have a video on whole house fans and the cons to them, and I get some people really upset at me about that video. And I just want to point out that they are trying to sell whole house fans to everyone in the United States of America. They're telling builders that this product will make every home better in the entire zones 1 through 7. That's from Key West all the way up to Canada, basically. So just be careful. If you're in a dry climate, awesome. I'm happy for you. Great, run your whole house fan. I'm gonna get a bunch of people commenting on this one too that like, I grew up with one and it was the best thing that ever happened to my family. That's great. I mean, comment if you want to. It makes the video more popular. But this is like not right. They need to not do this. Just to lighten the mood a little bit, AstroTurf, what do you call them? Topiary?
Topiary scalps, yeah.
Nice. That's cool. Can they go indoors too?
Yeah.
Yeah, they can go indoors. So as far as the shower, rainforest, car wash thing goes, there is a way to recycle the water. This is one example of it. It's called Rainstick. So basically what they've got is the, typical car wash kind of a system. But at the bottom, instead of letting the water go out to the drain, instead they're gonna suck it back up from this little bathtub they've got right here. And they're gonna go back and recycle it. And they say it's gonna recycle 6 times. They say that because they're augmenting that pump, that recirc, with a 1/2 gallon of water from the actual tap. So they kind of reduce the consumption from 1.5 gallons of water down to a 1/2 gallon of water. They say 80% water and energy savings. I think probably most of that would be on the water heating side, by the way. But it's nice. The 2 drawbacks that I see are, number 1, the filter that's in line is not, it's just a mesh filter. It's not gonna filter out the soap or the grime and the stuff that's sticking to the soap, the oils that are coming off your body. So basically they said that it's kind of like if you're sitting in a whirlpool, but it's vertical. So you're just doing like a whirlpool tub, but it's just like leaving the tub and spraying back out. The other thing is that little filter that's at the bottom inside the pump, you have to take that out and clean it yourself every 2 weeks. And we know that maintenance is like already kind of a problem out there. So just be careful, but this is one thing that if you want to chase after that kind of a savings, then you can do that. All right, I'm attempting to test this thing, and my particle counter is actually screaming at me because it doesn't like it. So yeah, this thing is putting out a lot of particles, and the reason for that is probably that we're not using super purified like RO or distilled water. So just know that if you're putting that in your house, it is, number one, a humidifier. We're in Las Vegas in wintertime, so it's pretty dry otherwise. But this thing it was pretty alarmed when I first turned it on. At the HVAC show this year, I saw lots of ventilation equipment. And this year, we're seeing lots and lots of air sealing stuff. We got lots of air sealing, weatherizing, insulated sheathing, things like that. Like it's good. This is going in a healthy direction. ForceField and ZIP are two of the integrated WRB sheathings that we talk about a lot on the channel. You've seen them on other channels as well. The guy who invented both of them, Landis Bennett, is a friend of mine, and I'm linking a video on screen now about him and about him talking about these products. ZIP was originally formulated as a roof product, and then the marketing team decided, why don't we just sell it for walls too? So it is over-engineered for walls because you're not going to walk on the walls. ForceField was his idea to like, hey, we don't need to be able to walk on walls. Let's make something that's a little bit less expensive. So we came up with this, and this thing performed really well in my house. We did a hurricane test on it even. Hurricane test. But now they've got it for roofs. And like, honestly, I'm touching this. It feels exactly like the stuff I put on my walls. So it seems like, again, the marketing team is like, well, why don't we sell it for roofs? And I can think of a couple of reasons. One is that looks real slippery. My roof, which was like just OSB, is hard enough to walk on a roof. Even with a 312 pitch, you might slip. It's possible if the weather conditions are just right. This one, I'm definitely thinking that you're gonna slip. Also, if water gets under there, it's gonna, like it's pretty easy to damage. So just think about these things as you're engineering this. This might be a good opportunity for you to use ZIP on the roof, ForceField on the walls. Two different systems, use two different tapes, but like, the right product and the right applications, I think, is the message that I mean. For John White and my other friends who don't like ceiling fans, there you go. That's what you need. Aren't you happy now? Foil-faced insulation, super cool. Radiant barrier on both sides. But if you're gonna set up an installation of this, you need to just remember that one of the properties of this is that it will be a radiant barrier if it's not touching something. So installing the wall right up on it, it's not gonna do what it's supposed to do. Also, it's in full contact at the backside with the OSB sheathing. So this actually, the foil won't really do anything at that point. This doesn't look like much, but this is kind of blowing my mind. So you put this much insulation outside of your building, and this is a steel stud, and of course, you're gonna have this happen. But what's interesting to me is that this is actually full of air. The screw is way down in there, and it's only this long. So you're just using regular fasteners. You're not having to get a fastener that is literally 6 inches long, which is a problem in a lot of the construction that we've dealt with. Also, a lot of the passive house guys will get really upset, guys and gals, will get upset about this length of steel through the thing, and I wonder if they would, if it was replaced with a column of air, especially since there's this kind of like what I might consider kind of a wall or like a little door on the top there. That probably is a lot less conductive than a solid steel or even a stainless steel screw that's all the way through your insulation. If you like the rain screen process for walls and potentially also roofs, this is the mesh kind of material that I sometimes will talk about with my clients and also on other videos. This is Ben Obdyke is the company. This one's called Slicker. It's the Slicker Classic. That would be fine for like if you're using lightweight cladding and you're going to be, screwing it on to the side of the house. and it's not going to crush that. It'd be pretty hard to crush it all the way down. It'll have some air gap. This has a little screen on the front of it, you can see, and that is for if you're going to do stucco or something that's going to be, you know, masonry, something like that, that you're going to be squeezing goopy stuff back there, which is the mortar. It might totally gum up just this. It would fill all the holes in it. So you need something to stop that from happening. And that's why they've got this, what's called Slicker Max. Any cooktop must have kitchen exhaust over the top of it. And you want it to ideally be like an inverted bathtub that's gonna catch all the spray, the like, you know, dribbly, weird particles and chemicals that are coming off whatever kind of food you're cooking, including toasties. Which is why I think that a flat surface like this is good for putting a toaster or an air fryer on top of it. So we got bowl shape, we got kind of bowl shape, but this is more like a trough shape. This is more like a flat panel, and this is where it starts getting like that's not gonna work quite as well. You're not using geometry. This would be a bowl if there weren't this giant panel here. This is basically like a linear slot drain in a shower, like that. Like that. And so we're imagining cooking fumes are gonna come up, they're gonna bounce on this, and they're gonna try and make their way across, and you wanna catch them right before they're gonna skip across this. And I kind of doubt that it would work that way. You see these big, pretty guys, I like that. But again, you got this flat thing that's here in the middle, and it's really cutting down on the geometry. This is basically the exact same thing as the Aria vents that we tested, these really pretty HVAC vents. They just don't have a lot of air space for air to move through them. Very interesting. Also, warm air wants to go up. So if you're gonna do downdraft, just know it's not gonna work as well. It will not, it cannot. And so what you need to do is you build something like this, and then you hope to God that the air is gonna come across and grab all of that air that's trying to go up and drag it back down. That's a lot more CFM you're gonna need to model into that thing. For my people who don't like ceiling fans, oh, nice. Okay, so you can hang these around instead. Is that better? You happy? Whew. Taking a break, time for a quick air quality check. I'm feeling real tired, and that might be part of it. But also, it's kind of dry here. We're looking at about 30% relative humidity. And the particle count, you can see we're still in the green up there, which is good. But, you know, there's stuff. But I think that they're doing a pretty good job ventilating this place. We have a new record on my airplane. Now, there are a lot of ERVs out there, and you want to know what exactly you're getting here. So this one is made to go onto the side of the ductwork. You can see the in and the out that just kind of like goes onto the return plenum there. This one is, you might recognize it. It's got, here, I'll point out some of the cool features. It's got dampers built into the thing. It's got an AI control system. This is a Broan. That's a Broan ERV. That is what they call is OEM. So they're selling this to Carrier for their name on it. That one, not so much. So just be careful. If you're getting a Carrier ERV, it could be the one that actually is made by Carrier, that was invented by them, that I'm assuming, that is like not gonna be, that's not the best design for, because you can't take the stale air out of the bathrooms, for example, with this one. This one is better. It has the name on it, but it's gonna do all the same things that the Broan AI does. This was my first pressure gauge, DG700. They're using it for something cool here at the Broan booth. So they're using it to show that their bath fan, when it has restriction in it, which they're using that damper for, is gonna perform better than the competitor. And if you know, you know. But that's something that the competitor is actually really proud of on their system. So I'm kind of, they said that it all has to do with the motor design and the fan design. So anyway, this thing has a side profile on it, which is kind of cool. And also it's got like a night light feature. Where's the bathroom? There's the bathroom. Here it is. Okay, so there's the light normally, but then you can turn on the night light. Ooh, sexy, I like that. So I thought that was pretty cool. And then also on their Virtuo enabled, the Virtuo is this thing on the side. These are the AI Series ERVs, which are kind of big and boxy. Like everyone can agree, those are some pretty hefty ERVs. That is a lot more reasonable if you're looking for space. So especially on multifamily, we have this issue of like trying to fit this stuff. So Scott True, I'm talking to you on this one. Here's another thing. They took the mount from the side of these and they put it right in the dead center of this. And they have this switch right here. That is the direction for the exterior. Is the exterior that way or is it that way? If you flip this, what it does is make these streams swap. And so that is gonna solve a whole bunch of problems. So the idea is that now you can just stock a bunch of these and they'll work in almost any one of your homes. The other thing that's really interesting here that I thought, that might be a problem, is that this core is a funny shape. Normally they're square. And the idea is that the air is coming through this way and it's rubbing up against the air that's coming that way. But it actually turns out that the efficiency on this shape, because it's actually longer, you're looking at the travel path of the air from here all the way down to here is actually longer than their square ERV cores in those big boxy ones around the corner. So the efficiency they're getting here is actually slightly higher than the ones that they're getting on the square cores. Anyway, that's a cool new thing that just came out. It'll be available in May, they say. My buddy Matt Hoots just let me know that Rockwool is really hard to get a hold of right now because like half the company went on strike in Canada. And all the other mineral wool manufacturers also decided to clean their equipment coincidentally at the same time. So it's really hard to get Rockwool. This is Havelock wool, which I have personally tried to use. And I like the idea, but just because it's sheep's wool doesn't make it more like healthy for your family, because you shouldn't be breathing this stuff no matter what. The other thing is that this stuff doesn't really friction fit into walls. That was my problem with it, was that I was using the 4-inch thick, the 3.5-inch thick, and it just wouldn't stay up. So I was having to wire it into the walls. And that's one of the reasons that people like me are recommending Rockwool, is because it stays where you put it. It's so heavy and dense that you just put it in there and it stays. You don't have to wire it in, even to the ceiling. Wood fiber insulation. This is refined, which means shredded. It's basically sawdust that's all put together. It says it's a flexible, press-fit batt insulation composed of refined, FSC certified, that's very nice, wood fiber, treated with borate. Borate is a flame retardant that also inhibits mold and mildew growth and deters insects. It does not say that it prohibits insects or kills insects or anything like that. So just be aware. I have in the tiny lab, in the floor, there's borate-treated styrofoam, which carpenter ants don't want to eat. This stuff, before I used this, I would make sure that it had been tested for termites, number one, and that we know that the carpenter ants are going to maybe burrow through it. They might not eat it, maybe they won't, but it deters them, it doesn't stop them. So just be aware of that before you start using it all over the place. All right, this is cool. Okay, so we got exhaust fans, we have this kind of like a penetration that normally has kind of just been made up by people. There's different solutions for this, but one of the things that I just want to point out is in every exhaust fan, if you're using bath fans in your house, inside here, there is a damper and it has a piece of tape on it. It says, remove this tape before you leave this fan. When you're installing it, you've got to take the tape off. That's one reason why fans wouldn't work. Here's another reason. New technology, new solutions. Pull out the red cover before installing the roof cap. Who's going to install the roof cap? Is it perchance the roofer? And does he actually read English? These are the kinds of things that we just want to make sure that we're super clear about, is that like, know where all the possible stoppages are in your system before you blame it on the fan itself. Because you might replace that fan, but it was that all along, and a new fan is going to do the exact same thing. How about a revolutionary new filter that you can see through? Don't you want that? Don't you want that? You don't. Because yes, bacteria and viruses and things are like spooky, but you can just capture them with a HEPA filter. You do not need what this is, which is an electronic air cleaner. The electric field that this thing has to induce to grab as many things as they're advertising for the 99.9% capture is pretty huge, and that will create ozone. And it will be a chemical reactor in your airstream, and you just don't know what's going to happen with that. So like, since we don't know what ingredients are going in, we can't know what ingredients are coming out of this thing. And these companies are not testing for that because they might not even know about it, they might not care. Remember, people, if you are going to be adding a towel warmer to a bathroom, tell your HVAC designer, because these could add a significant amount of heat to a small bathroom, especially if you're just going to keep it plugged in and on 24 hours a day in all seasons. partly because we are not going to be adding air conditioning vents to small bathrooms because they've generally got such a low load. Shout out to the only booth I've ever been yelled out of for asking too many questions. And I get to meet people that I haven't met in person. These are our Patreon supporters. So this is Daniel, Mercedes, we got Brooks and Bill, and you're a builder. But everybody else basically in the Patreon group is just like a normal person who's doing projects to renovate or build an addition or build their dream home. And this is like a fun little first time where we're meeting in person. We get together every 2 weeks over Zoom. You say what you just said. What does your 7-year-old daughter say about the show?
Oh, she loved watching the episodes. Every time one ended, she's like, let's watch the next one.
Hell yeah. Science of homes. And you guys having a good time at the show?
Yeah, it's exhausting.
It's exhausting. Yes, true.
A lot of fun. Yeah.
And Brooks is in charge. You self-appointed as the training director of your company.
Yeah. I just forward on your videos to the guys.
Don't mess.
Somebody just asked me, are these giveaways? Can I take one? And I said, please don't. They're not good for your family. Let's take a moment to acknowledge the beautiful ductwork. I am a big fan of pretty vents.
We're in
and
third
these
generation family
are
business.
some of the prettiest I've ever seen. Look at that. Beautiful. It's like a little heart. We got hot tubs and ice tubs. And Grace told me that actually there's this funny thing. The scientists did research on it and they found that just filling a salad bowl with cold water and then dunking your face in and holding your breath for 30 seconds gives you all the same physiological feedback as dunking yourself into an ice bath. So you don't have to do this anymore if you don't want to buy one. Get a salad bowl. This is a map of what you could do with your home if you used HVAC, the special HVAC, the right way. My thing is, that is what a normal house looks like. Every room is a different temperature. Isn't that what we're trying to avoid? Isn't that what we're like doing better than, is this? All right, at the FLIR booth, I like FLIR because they have a lot of different kinds of things that all circle around the 5 factors of ventilation. This is their evaporative humidifier. I've generally talked about this as like a gateway drug to their steam humidifier, but this one's kind of cool because Joseph Hillenmeyer, my buddy at FLIR. So this is cool because they redesigned it and it's actually got a fan built into it now. And the fan enables you to install this whole thing on the supply. So you're able to take hot air and pump it through this, which is the whole point. That's what makes the evaporation happen a lot better, without having it take air from the supply, shuttle it over to the return. And I've got a video on this that hopefully I'm showing on screen right now if I can remember it. There was a short that I shot of like a horrible install of one of these. And it's just like, it's just not the beautiful system because it sends that humidified air through the filter then and makes the filter a little bit damp maybe. Also, if you accidentally run it in cooling season, then you have like a whole extra layer of issues. So this is a good, I like that. That's a good way to revamp. Over there is their ERV. And that historically was kind of like a vanilla ERV. Can I say that? Can I say it was vanilla? Okay. Now they actually did some stuff to it. What is the new things in the ERV?
So it's 2 independent ECM motors, so you can set that speed separate on the exhaust and the supply side. We used to have a single motor with 2 squirrel cages on it, so you had to use balancing dampers, which works, but you're choking down airflow. It's much more obviously effective and efficient to have 2 independent motors. A 72 SRE, which is the sensible recovery, which is
nice.
A combination of the core performance along with how tight the cabinet is, and then 1.45 CFM per watt at the highest speed, better than that at some of the lower speeds, and over 2 when it's delivering max.
Nice. And that's code, by the way. You want to think about that because like if you're buying these, letting your HVAC guy buy some crappy brands from the distributor for you, like it's just not. I've seen a lot of people, like I say, buy this, and then their guy comes with like some other thing that's not. It's 1 speed. Get the EC motors, all that stuff. So the other thing that you wanted to, I wanted to talk with you about is this UV. He's like, we did come out with a UV thing. And I was like, Joseph, you know what I'm going to say. But he immediately said,
The use that we're recommending it for is to put it over the coil, and it's going to prevent microbial growth that can occur on your coil. Not to put it before the filter in an attempt to kill things traveling through the air, because air passing under a UV light, it's not spending enough time under there to do things. UV sunlight does kill things, but it doesn't do it in a millisecond. So we're focusing on what we can do with UV, which is help treat the coil.
So flat out, trying to UV sanitize air is dumb and it doesn't work. Please stop buying those things that they're trying to sell you at the HVAC supply shops. Homeowners, don't let your HVAC guy put those in if that's an easy silver bullet. Thank you very much for making something that actually will do something. Cleaning your coil with that is a lot easier, and that is an okay use of UV. Sometimes you walk past one of these booths and it's like, what exactly is this that I'm looking at? This is it's called LightCon. It's a very lightweight aerated concrete. You can see it's got bubbles in it. It's about R1.2 per inch, and it comes in 2-inch or 3-inch thick. And then what's cool about it is that you can use it for all kinds of different things. So it comes in like 2 feet wide by 8 feet long, up to 8 feet long. You can get it in 4 feet or 6 feet or whatever. But you can use it on the walls. You can use it as subfloor. It's also fireproof, obviously, waterproof, obviously, and then it's going to be kind of an acoustic insulation as well, so it'll be quieter than just a solid concrete wall. It's just interesting. If it helps you, then great. LightCon is the name of the company. So Matt Reisinger has a video on this new Pella flange system that allows you to install windows from the inside. And so if you're not following Matt Reisinger and you're interested in this stuff, you should be following him, number one. Number two, this is kind of what we're dealing with. So I was sitting with a new friend of mine yesterday, and he was talking about how like there's not a lot of innovation here. And I think to people like me, it's like there is innovation, but it's not things that you would call exciting. They're pretty dumb things that we should have done about 50 years ago, and it just takes a really long time because we're so busy selling stuff that they stop the engineers before they can actually perfect the thing, because they're just like, look, you gotta stop. We have to sell this thing now. It's good enough. Let's just go to market. So that's kind of like where we're at a little bit. By the way, Pella's not, that's the brand that's in our tiny lab. So it's a good brand and everything, but it's just like, duh. You guys, Vulcan Vents, we tested this. This is a great ember resistant and flame proof vent for your home, for crawl spaces, attics, stuff like that. You've seen it before. This is Nate and Eric. There's some new stuff that I'm going to show you in a minute. But basically, just to review, in between that honeycomb right there, the honeycomb is an intumescent coating, which means that it basically acts like a bulletproof vest. And it expands when flame comes close to it at about 500 degrees. Is that right, 500? It activates and it blows up. And if you want to see the video on us testing these things for both the flame resistance with a torch, it was awesome, flamethrower that Grace had, and also for airflow, which is much more important because these are supposed to be vents and they're supposed to admit air, then you can see that. They have it, by the way, in copper, like honest to God copper, if you want to spend the bucks. But this is one of the new things that they've got. In California, there was a disaster that happened with a balcony and some kids dying, falling off this balcony when it collapsed because it was rotten. So they have since required that every 6 years, is that right? Every balcony that's enclosed in wood on all sides needs to be inspected to make sure it's not rotting. And they need to be ventilated. And so now we have vents that can be inspected. And this vent, of course, because it's from Vulcan Vent, is going to be the ember proof and also flame resistant with the intumescent coating. It's expensive. Homeownership is expensive, and it's getting more so as we have these disasters happening and all this stuff. We've got a couple things. So one is, if you are being told by your insurance company that you have to have some kind of ember resistance on your screens, you don't have to go all the way to cutting new, bigger holes in your crawl space walls and your foundation and your attic and all this stuff and making that happen. You can take your normal, like nasty old screen that you needed to replace anyway, let's be honest, and you can now get a replacement screen from them that actually meets the testing standards that IBHS has said, like, this is what it needs to be, and you just screw it on to the faceplate of your old vent. This is not the flame-proof kind. By the way, it's got this cool, you see that texture on it? Isn't that nice? I was like, what is the texture for? Is it some weird science I'm not aware of? And they were like, nothing, it's for nothing. They use it because they're using it on this gutter ember resistant vent. And it's for your gutters. We've seen these before, gutter protectors. What I thought was cool about this one, even though I know and you know that, like, probably if you're not a good maintenance homeowner, then you're just gonna get a big pile of leaves like piled up on top of your gutters instead. So like take care of your houses, okay? But here we've got this texture built in so that if you've got a wet mat of leaves, the texture enables you to have still water flow down into your gutters, which is very important because that's what the whole point is. So anyway, there's like, it's not expensive. You can do this stuff and you can prepare your home for the things that we're worried about in season 3 of Home Diagnosis without breaking the bank. There are options. Blower door, it's one of my favorite. Okay, so a couple new things. It's not here, but they have a lightweight blower door, which as I'm getting older, I'm thinking like, that might be interesting. It is more expensive. It's like considerably more. This new blower door setup with the new gauge, this is the one that can do data logging and all kinds of cool stuff, is about $4,800. The new lightweight fan that can run off batteries is like $7,000. So I'm probably not going to be investing in that, but there's this. If you're looking for a deal, this is their like bare bones 1-channel manometer, and this is going to be, they promise, $400 or less. Nice. Because when you're using an HVAC manometer, they're not going to be as granular and as accurate and precise as one of the home performance manometers. So until now we've had the DG8, which is about $600. This being $400, I think is really good. This can't data log or do anything special, right?
It would be able to, because it's USB-C, so we'll obviously have a program.
It has a USB-C on the top, so we can get this
data
thing.
log with a computer.
Hell yeah. All right, cool. So this it will be, I think, very important. If you're going to do a blower door test, you would do zonal pressure testing, you need at least one of these things, if not a whole nother one of those. We still have the smoke machines that, I don't have these, by the way, and I tease them about it a little bit. This one is like $1,800, $1,620, and this smoke puffer is almost $1,000. And they know, you don't have to say it. But so you know, smoke puffing is good. They're coming out with a less expensive version in the future. He's nodding. All right, I like it.
It's already been said. So.
Nice. And then lastly, of course, that flow box right there, that's like another $300. If you're going to get a blower door set up, you need one of those because you're going to be able to do pressure pan with it and test exhaust. All right, so we're looking at Panasonic ERVs. Big, very, very big. Ken Nelson, my friend, why is that one so big?
Again, it's all about the core. This thing has a large core. We're looking at 80% efficient on the energy transfer.
On sensible or on both?
Sensible.
Okay.
It's about 70% on latent.
Wow.
No, it's remarkable. I love this device, but you're right, it's big. I mean, I need space to put it. I've seen it put in crawl space. I've saw it put in an attic. I don't like that application because it's
Outside the condition envelope?
Well, even so, every time you get near an attic or out of that space and I have to have a filter change or something like that, it's somewhat problematic.
Is it quiet?
It is remarkably quiet, and that's part of this can, right?
Are you guys still manufacturing HRVs?
No, we've never manufactured HRV.
Hell yeah.
Panasonic is not a fan of the HRV. We think that it's imperative, the efficiencies are actually more for the house, moving water vapor when I have high amounts of water vapor, but I also want to balance water vapor, right? I don't want to dehumidify the entire property. You know, we hear about HRVs in cold climate, and I'm like, you know, that's not my friend because I'm just dehumidifying the heck out of that house. The ERV always wants to find balance between outdoor air streams, indoor air streams.
And as Ken pointed out, you want to make sure that these things always run continuously, and that if you're going to pair it with a dehumidifier, you put the ERV first, then into the dehu, because you're just passively knocking down the top. I'm linking on screen the video that Ken was in with all the ERV manufacturers, the ones that I think are like the top 5, talking about using their products to exhaust from bathrooms. Thank you very much for your time.
I will talk to you.
Okay, so one of the things that's always confusing to me as somebody who has built a couple of houses, and like, there's just too many sealants. So we're at Sashco, this is Lauren, I'm just gonna hand it over to her. Why do we have so many different kinds of sealants? Why don't we just have one?
So Exact Color, Slab, Big Stretch, Moreflex, Clean Seal are all of our water-based sealants. Lexel and Through the Roof are our solvent-based sealants. Exact Color is our water-based latex sealant. That one's a very special sealant that matches infinite number of colors. So you can put 20 milliliters of that paint into the tube, shake it all up, and you've got a perfect color match. So that's one of our favorites for colors that you can put anywhere in your house: windows, siding, doors, frames, kitchen, bath. any kind of application you can kind of think of.
So would it,
It would
replace
be-
like most of the rest of these? Like
Not quite, no. So our slab is textured to look like concrete and fill horizontal flat cracks in the ground. So
because
that
it kind of like self-levels?
No, it doesn't self-level quite exactly how you would say a concrete would self-level, but it'll fill that crack and then it'll match the texture of the concrete and have sand and mortar and grout in there so that you get a really good texture feel to your concrete. It'll stretch as the cracks grow.
Okay, cool.
So that one's formulated specially to be put in a horizontal surface.
Okay.
Our Lexel brand is our use literally everywhere you can think of kind of sealant. There's a couple things that we recommend you don't stick it to, like polyethylene's really hard to stick to, Kynar is really hard to stick to, but that's pretty much with every sealant.
Yeah.
Your two main products, these are formulated very similarly, but the through the roof is our extreme temperature, better performer on roofs where you've got up to 140, 150 degrees Fahrenheit during the sun, and then it doesn't slump and fall out of the joint as much at those high temperatures.
And then what is this active enzyme caulk for kitchen and bath?
Your water-based sealants have a lot of, we call it bacteria food in them, that eventually if you don't keep them clean and scrub them, the bacteria will just eat at your caulking and dissolve it. We put an enzyme in there that kills the bacteria before they can even start to grow.
Okay, and so let's talk about Big Stretch, because that's come up a lot in the high-performance building world with air
For sure.
sealants.
Yeah.
What's special about that one?
That's the acrylic latex-based sealant. And that one we formulate very, very effectively to make it stretchy and pliable and move with your building. So compared to a lot of our competitors, instead of making this sealant that's hard and doesn't let water through and pretty sturdy, ours we formulate in the same way where we don't let water through, we prevent humidity and gas exchange and all that kind of stuff, but it'll move with your building a lot more efficiently than a lot of our competitors. So it's softer, it likes to hold on to both sides, stretch, and then reform its original position a lot easier than, say, a standard silicone where you pull it apart and it's just hard and hard to hold it there, and then eventually it'll snap. This one will move and kind of just reform its integrity and internal structure to keep its bonds where it needs to be.
So on, for example, places where you're meeting two different materials that are going to expand and contract at different rates, that's where you would, so like concrete wall to the plywood substrate of your sheathing. That's the kind of thing.
Do a big stretch, yeah, unless you want it to be textured and have some sort of filler in there, some sort of sand to physically match what you're seeing.
You guys are getting a little uppity asking for these textures and these special colors, I think. But that's okay. Have what you want. Thank you very much for coming up with the good stuff. Builder Show, tiny house on wheels. So we'll test the outdoor particles now and then test them again inside. All right. So we have an all-in-one washer dryer. So that's 150 CFM. That's normal for a window. So we got a shower. On the other side of the room, we got a 70 CFM builder grade Broan through wall fan. That's Broan makes some cheap stuff too, for just in case the builders don't want to spend too much dough on that. That's 6 zones. That's pretty loud. Some people prefer that. Kitchen exhaust fan. Rated for 160 CFM.
Me and my sister on rollerblades.
That's so funny.
Yeah.
Yeah, it's wonderful.
I know.
65 to 165. We can do full custom
All right.
what kind of finishes you want. And
Thank you. This is a 1-ton Mitsubishi mini split, 400 square feet, 10-foot average. That's a ton. That's 400 square feet per ton. That's not high performance. So definitely AC is oversized. We have not just the kitchen and the dryer, like I suspected, and the bathroom on the other side, but also the fridge in here is a propane, it's called a dual fuel fridge. This is something that RVs use. That's a hole for the breathing of the propane portion of the thing. And as far as I understand, when we research it for our tiny lab, that is not airtight. Like that little combustion chamber is not airtight. So that's kind of a hole in the side of the house. But you've got the kitchen at 160 CFM, you've got a 70 CFM bath fan, that's 230. And then we've got, on top of that, the dryer for another 150. So that's 380 CFM. And the pressure that that probably induces on this, that's gonna be a lot of pressure. And there does not appear to be makeup air for this system. So, just FYI, think about that. You can't use bath fans in very, very tiny homes that are airtight. And you shouldn't use bath fans in like regular sized homes that are very, very airtight either, because they end up being really problematic. So many tiny homes, lots of modular and pre-built. That is a 3-ton heat pump on a 400 square foot, which is 130 square feet per ton. We're just getting worse. We got a lot of ones that are built black, and no ventilation on any of these. Also no eaves. Like, this one is not even made to go on the road. It's supposed to be manufactured and plopped down. Why are there no eaves? It just feels like the designers are allowed to do a lot of stuff that we should be having more science in this conversation. All right, this is called the New American Home. They drove us 45 minutes to get out here and then told us when we got off the bus, you have to wait an hour and a half in line even to get into the house. Then the tour is 45 minutes. So not gonna do that. We're gonna continue this conversation with the photos and the floor plan and all that stuff that we can see online. Another thing is that I just have to get off my chest that I do not worship rich people. I think that conspicuous consumption is a little bit gross, and I think that the divide between rich and poor in this country is potentially the central problem that we've got. We're going to talk about science at this point, but I think that there are some things that obviously they're doing good in here, and I'm going to talk about those using just the information that we can find online, since I'm not allowed to get into the house. I will also say that there are definitely some things that we're missing, because like most homes that are show homes, that are showcases of all the best builder stuff, and this is the National Association of Home Builders, who historically and even right now is fighting against a lot of high performance things and healthy home things, because they kind of try to make all of their members happy. Some of them like to do old style building, and they don't want to have to do new codes and all the whatever. So like, I'm not really a big fan of National Association of Home Builders. I think that they're on the wrong side of the argument a lot of the time. And in this country, we're like pretty far behind what is really possible. Like I said, some good things, some things that are probably problematic that I'll point out. Here we go. All right, I don't want to bore anybody, so I'm gonna try to blast through this as fast as possible. Here is the final performance report for this home that they've built as the show home. Now, first of all, thermal envelope, they're gonna get to this. I just want to point out that this is the most inefficient way to build a home. Single story means the most amount of surface area per volume of interior space. So if you're gonna try and build more efficient, try and stack floors on top of each other. Also, bump ups and like bump outs and all this stuff just increases your surface area again and number of corners. They are paying attention to the western facing windows, and they're adding extra low E coating, which lowers the SHGC solar heat gain coefficient. That's good. They're talking about an unvented and air sealed attic. They don't say conditioned, which is my preferred way of talking about it and of doing it. But it's not a right way, wrong way. Some people don't like to say it's a conditioned attic. They like to assume that it's going to be a certain amount of degrees north. They're talking about overhangs. That's good. Always do overhangs. If you don't do overhangs, you're asking for trouble. They have used aero barrier, which is like fix a flat for a building envelope. And with that, they were able to achieve, and by the way, I'm going to talk to aero barrier at the show in a minute, so stay tuned for that. With that, they achieved a blow order test of 0.35 ACH50. That's very impressive. That's better than my blow order test on my house. We're going to talk about what that means in a few minutes. As far as HVAC goes, they have variable speed equipment, which is like not even 18 SEER. And by the way, don't poo-poo that. That's good. That means probably that it does a little bit better with dehumidification, which, do we need it in Las Vegas? Maybe not. But low SEER doesn't mean bad. It just means that like they're not cheating the SEER to try and to get points. Mechanical ventilation provided by Broan Newtone's AI Series. That is some of the best equipment going for home ventilation. We'll look more into this in a minute. Space conditioning system, totally inside the conditioned space. That is the first thing that you can do to make your HVAC system more high performance. So good job on that. They're touting here the fact that it's going to get a projected HERS index before solar of 54.
After solar, it's like negative 45. Don't pay attention to that number too much because that's just throwing money at solar panels. 54 is a respectable HERS index. It's not like incredible, but it's doing a good job. And then we've got MERV 13 filtration. That's good. That's above what code is going to require. Code will require MERV 11 at the very get-go. This is like pretty good for human health. HVAC ducts are sealed during construction so that you don't get dust in them. That's awesome. Everybody should be doing that. That's like no-brainer. Correct amount of fresh air coming into the home with the ventilation system. We're going to also look at that in a minute here. Here is the plan for the house. Now, down here, past this garage, there is this little casita. We might touch on that, but I'm not going to count it as part of the house. So we're talking just the main living body of the house. We get 7273 square feet of living space in the house. 7,000 square feet, 4 bedrooms. It's a little like disproportionate, but you know, with all due respect, SunWest, the company that's building this and designed it, is building wealthy homes for wealthy people in a wealthy neighborhood. I had an idea that like, oh, why don't we have, you know, since this is a show home for the builder show, let's have Scott True build like an affordable home that's high performance right next to it. And of course, nobody's going to let them do that because this is a wealthy neighborhood. And as soon as they're done busing people in here for the show, they're going to turn around and turn this into a gated community and they're going to sell this house for a ton of money. So good for them. Rich clients are nice clients to have. But one thing to point out is that this is the west facing, and you can see all these windows. Oh no, on the west face of this. That's going to really kill the HVAC loads in the summertime at 5 o'clock in the afternoon. But look at this. Like, that is why you face your windows west, is because this is the view. Obviously beautiful and spectacular and stunning and all that stuff. It also felt a little bit like looking down on the plebes in the valley, but we won't get too philosophical here. So we've got all these, like, I'm going to try and avoid all the sponsors as we go, but we could see that we've got lots and lots of glass on the backside, which is what we were looking at. I'm trying to go over here if I can avoid this is like playing Frogger. All right, I want to look at this. So outdoor kitchen, awesome. This, totally awesome. Outdoor kitchens should also have exhaust hoods. Exhaust hood, kitchen exhaust hood is the most important thing you can do for your family's health. Also, if you want to keep this from being all greasy, then this is totally necessary. So that's great. Have your pizza kitchen, have your grill, have them outside the house. That's the best place for them. You turn right around and you've got the indoor kitchen. So we'll come over here and check this out. This is a good setup. They have 2 islands in this kitchen. Right, 1, 2, and I'm glad that they didn't put the cooktop on either one of those things. This is the right place for it because we're limiting the geometry of what's going on. It can only take air from the front, and we're also limiting the geometry on the sides with these cabinets, so that's really good. Now this cooktop right here is what looks like an 8-burner. I looked this up, and it's this thing from Signature. So what you want to do, if you're going to size your kitchen exhaust, is you want to count up the number of burners, and you get to count all of the BTUs. When you add all these up, you got 15, 15, 23, 23. These are in thousands of BTUs. Plus, we got these 2,000 BTU induction units that are each 2,000 on each side. So we've got a total of about, when you take the wattage, you multiply by 3.41, and it gives you the BTUs. So we've got a total of about 100,000 BTUs of cooktop power. Now, the way you size this normally, nominally, is you're going to take for each 10,000 BTUs, you're going to add 100 CFM of cooktop exhaust. That would give us 1,000 CFM exhaust hood. But when we look at this thing, again, this is this right here, which is what actually Signature recommends to put with it. And this thing only blows 650 CFM. So that is a little bit dangerous to not give whoever you're going to sell this house to the power to completely exhaust all of the whatever you're going to do. This is kind of assuming that you're not going to use all 8 of the burners at the same time. I don't like to assume stuff like that. So first of all, this is undersized by about 350 CFM, but let's just consider that if we wanted to do this, we want to size the makeup air. We can use Broan's makeup air damper specifier. We put in all this stuff, blah, blah, blah. You guys, if you haven't seen me do this on the channel, I'm hopefully linking a video right now. You can also look up makeup air on my channel, and you'll find multiple videos about it. So if we've got a 650 or 660 in this case, CFM exhaust hood in the kitchen, and we want to limit the depressurization in the house of this size with this blower door test, then we have to have, if we're just going to poke holes in the side of the house and have mechanical dampers open up and allow the pressure to be relieved, we're going to need 7 8-inch dampers to outside and 1 6. Or we can have 4 10-inch damper ducts and 1 8. This is a wealthy house in a wealthy neighborhood for wealthy people. There is no chance that they did that to this house. So I think the fact that they weren't bragging about the makeup air or the kitchen exhaust in that performance report, and the fact that if they had bragged about the active makeup air, which is what they would have to do to actually do this right, I don't think they've got makeup air in here. So let's look at some of the implications here. First of all, let's go through the plan. So we've got right here, we have the mechanical systems. Now let's go down here, and I've just circled some like basic stuff. First of all, I love ceiling fans. Great job, because in a higher performance home, even though this one is single story, it's got what looks like code insulation in the roof cavity. It's going to be like, you're doing better if you get that air tightness in there. So ceiling fans are good because you're going to lower the load. HVAC system is going to be smaller. We have a bath exhaust fan, and it's over the toilet in this bathroom. There's a shower right down here that it should be actually in. And in fact, if you would put this thing in the shower, the air comes in under the door and goes across the bathroom and hopefully would grab the odors around the toilet on its way out over the shower. So that could be a 2-for-1. When builders call this a fart fan, they end up thinking that that is what it's for, is farts. So that's not very healthy. So moving up, we have a powder room with a fart fan. And in this case, yeah, there's not a shower in here. That's what it's for. You put it over the toilet. That's fine. Laundry room, they've also exhausted. I think that's good. I always ask my clients, do you have any need or desire to exhaust out of your laundry room? Here in this bathroom, we don't see a bathroom exhaust location anywhere on here. And that's, I think, just a typo. I think they just forgot it, because if you move over here to this bathroom, which is basically the same layout, they have put one in. Again, they put it over the toilet, which is the wrong place in my opinion. And in actual practice, that's the wrong place. As we move up, we can see that we've got a master suite with a powder for her, a powder for him, so you can go to the bathroom at the same time, each of which has a bath fan. And there's no bath fan anywhere in the shower or around the shower. So again, I think that that's kind of a mistake. Just because it's Las Vegas and it's dry doesn't mean that you should allow the humidity to spike terribly for like an hour a day and then go back to normal. I think that that's not great. Now here, one of the things that's interesting as far as the enclosure goes is that we've got all these glass, this west-facing wall at this bedroom, which is beautiful, but major heat gain in the 5 o'clock hour in the summertime. They have a powered drapery and curtain track on the inside. That's very nice, but if you consider that once the heat of the sun's rays have come through the window and they hit the backside of those drapes, the heat is in the house, and now you have to deal with it. Better would have been to have powered, if you're going to have a powered something, put powered shutters outside. Then the heat is not making it inside the house, and that'd be cool. We don't have to worry about that right now because we're going to move on to ventilation. Now, here's what I want to say about the air tightness. We have a total conditioned floor area of just the house, not the casita, 7273. We've got mostly 12-foot ceiling heights. That's like the roof, I believe. And we've got a few, like about a quarter of the house is 16-foot ceiling heights. So that's a total approximate volume, which I've just, calculated here, of about 95,000 cubic feet. For a blower door test that would give you 0.35 ACH 50, that's a CFM 50 of the blower door reading itself of 552 CFM. That means that if we blow 552 CFM of air with any devices out of this house, we are doing a blower door test. Now let's look at what they have installed in here. All those bath fans, they weren't extract points for the ERV. They're actual, honest-to-God bath fans. They have 7 110 CFM bath fans. They have 4 80 CFM bath fans. They've got 2 in the garage, which we're not counting for this, like what I'm worried about right now is depressurization of the house. Exhausting out of the garage is fine. That's good. That's the only way to make sure that the garage is depressurized with relationship to the house so that you don't have infiltration the other way. We also have 4 150 CFM ERVs That's 600 CFM. Now I'm going to assume that one of these 110 CFM bath fans and one of these 150 CFM ERVs is for the casita. So we're going to subtract that when we talk about this in a minute. They also picked these concentric ERV terminations and the controllers. And I want to show you this stuff real quick. So first of all, this is the bath fans that are the 110. They've got this little blue light in them. As far as I understand, these are like not nearly as dangerous as actual UV lights. And so, does it do a great job of killing things? Probably not. Is it going to be super dangerous for your family? Probably not. I would say it's like, it looks a little bit like window dressing to me. No offense, Broan. Bath fans, yay. Bath fans. Energy Star, great. Pick Energy Star anytime you can. Now, as far as the ERVs go, this is the 150 CFM ERV. This is what makes these ERVs special. This is why everybody's talking about these Broan AI series, is because this box tests itself. Not just when you set it up, but also twice per second ongoing, and make sure that it does exactly what you tell it to. That's cool. These are the concentric vents. Now, these are like worst case scenario, in my opinion. Normally, you'd want to have the intake and the exhaust at least 10 feet away from each other, because the air is just not coming out of this that fast. So is there a chance for feedback? Yes, there is. And in fact, I believe that they allow them to feedback 10%. In test conditions, which is like involves no wind, I'm sure, or anything like that. So I had a manufacturer of a system that does this and only does this. You can't like set it up a different way. Say, oh, well, Broan does it and Panasonic do it. And it's like, okay, but they only do it when like you can't do anything else. So I think that this could be done better. Here's the controller that they picked. And they've got 4 of these. I like that it's full color. You can see all the stuff of like what is going on with the ventilation system. I will say that this is interesting. The fact that they screenshot on the recirc mode. This is something that Broan ERVs and a few other ERVs can do, which is actually against code in some places. It means that they close off the damper of the outgoing air, and they actually have the outgoing air, the stale air, turned around and come back into the house. And that's so, I think it's so that you can kind of like build some more energy efficiency into it and potentially also defrost the core. And I think that there might be some other things in it, but I would just say like in general, in my practice, I'm only recommending ERVs if you're going to use them as bath exhaust, because you can't use bath fans anymore, in which case you would never want to do this. That would be a total disaster. Now, going back to this ventilation count, the total ventilation possible with all those bath fans that we just added up is 980 CFM of bath exhaust. Plus, remember we had this 650 CFM of a kitchen hood that I don't think got made up. So we could possibly suck on this house with 630 CFM combined of depressurization. And that means that for this blower door test, we would be doing 252 pascals of depressurization. That's 5 blower doors. That's also called 1 inch of water column. That is a huge number. And I think that that is super dangerous to build that amount of capacity into a home, because you don't know what people are going to do. People are sometimes crazy or weird. Now, as far as the correct amount of ventilation, you do the ventilation calculation. And what they've got built in here is 450 CFM, if we count one of those ERVs for the casita. We got 450 CFM of balanced ventilation also on top of the bath exhaust. And when you do your calculation here, you find out that I am finding out that the house needs 255 CFM continuous, but it's getting 21 for free from infiltration. So we really only need 235 CFM continuous every minute of every day. We have 450 built in, which means we basically can do a 100% additional boost mode. I think that's a mistake. I think that considering that this house is so big, thinking about the first 50,000 cubic feet of air, which would be basically like, that's a pretty big home already, as one tier of air that needs to be replaced, and then thinking about the second 50,000 cubic feet of air as simply cream on top. It's a buffer. If you have pollutants building up in your house, that extra 50,000 cubic feet of air is going to kind of absorb that, and then like you don't have to worry about it for a couple of hours. So I think that giving a house this big a 100% boost capacity is a mistake. I wouldn't even give it a 50% boost capacity. I would give this house a 30% boost capacity. So I'd give it from 235, I'd add 30%, I'd come up with like 300 CFM total. So you'd only need 2 of those 3 ERVs.
All right, I'm at the Aero Seal booth, which is also Aero Barrier, with my friend Caleb, and he's going to explain something that I thought was interesting. So I've heard that when you guys Aero Barrier, you're using this fan over here, which is he's being stood in front of. That's basically a blower door, right? That's what you're measuring the airflow with. It's creating and measuring the airflow. When they come along later and do a blower door test, it's higher. And you actually you were like, yeah, you're saying we sealed it to 1.5 and then you saw a blower door of 3. And that's normal.
Yep,
and so how does that work?
Yeah, so when we go in and work with the builder, we get a contracted amount of ACH. We say, hey, you're going to model at 3 ACH 50 for all of your houses for a final. So what we do is when we go in to do a house and we do a test, we know there's going to be leakage in the windows and there's going to be leakage around the doors, around your weather stripping, etc. And so what we do is when we go, we prep that, we cover that, and we make sure that that natural air leakage is not going to be sealed by Aero Barrier, and it has to have an entrance for the door and the windows. So we cover that, and we actually calculate by the manufacturer, by the product type, of what the leakage is going to be. So if a final number needs to be at 3 and a final blow door, we've calculated the delta to be 1.4 air changes. So our target at a minimum has to be 1.6 or better on our metric to know the final is 3.
You would sample a few of them. You would do the blower door test before. You'd go with your Aero Barrier machine, seal it up, get the after, and then you go back with the blower door and you test it again, and then you find out what it is that you're taking out of it with your prep steps.
Correct. We find that number and then we go even a little bit further to make sure we have headroom so they pass every time.
Nice. Okay. And so if you are, they tell me that the builders all know this. I am under the impression that builders are very, very busy and that they might not understand a lot of this stuff. So just in case you see that happen in real life, know that this is something that is, this conversation did happen on site, and that they did tell them hey, our number is not the final number, it'll be higher because we're going to take all this tape off.
That's great.
So this is Eduardo, and sometimes you meet people again at shows, sometimes you meet them for the first time, and I just heard you talking about something that is a problem in the published data of the air conditioners and the heat pumps. And you're based here in Las Vegas, right?
Correct.
So what is the problem?
Usually the manufacturer data only goes to 110, 115 degrees. And the reality is that some of these units live in conditions where you're reaching 120 to 130 degrees temperature, especially outside temperature, especially out here in Las Vegas where you get that radiant heat coming off the roof.
And especially, when you've got a multifamily building or a casino you were talking about where you've got the units mounted on the roof, so they're there's no shade, they're going to be beat on, and then also the heat of the roof material itself. That's very interesting.
Yeah.
So you were giving them a hard time. Panasonic now has heat pumps and things like that, which I'm excited about because we need more competition in the marketplace. How are you solving that right now? Are you just over designing?
We have to accommodate and extrapolate unless we get factory data.
How do you do that? Are you doing homes as well?
We're doing homes.
Okay. And how do you, in a manual J, how are you giving it a little bit extra to make sure that the manual lasts?
We don't. We have to add supplemental systems to make sure that...
Oh, okay. So you just have a secondary system to pick up?
Correct.
Okay. I mean, the party load system is kind of what we're talking about. But it's for extreme weather. Thanks very much, Eduardo. Awesome, man. So that's what I saw this year. I tend to walk about 5 or 6 miles a day when I come to these, so just know that. Bring good shoes. I hope that you have learned something, and feel free to comment below if you have things that you wanted to say about the specific products we talked about, or wanting to see more stuff in this kind of a video next year, which is also in Las Vegas. Tune in next time.